So in the last few sessions, we have been seeing how to query some tables. But if you observe, we have always queried via a single table, right? We have not referenced 2 or 3 tables. We just fire our queries against a single table. Now, in real world, most likely you will have to query multiple tables together, right? Data is actually shared across multiple tables. And that's where we use the concept of joins. So joins is nothing but, it's a syntax, it's a query which helps you join 2 or more tables based on certain criteria, right? When 2 or more tables are to be joined, there will be at least one column which is common across both the tables, and we'll look at a few examples. And this is one of the most commonly occurring scenarios where we have to join 2 or more tables. So depending upon what kind of data you want to retrieve, in the sense if you're joining table 1 and table 2, do you need just the common rows, or just the rows which are from table 1 and which is matching from table 2, and various scenarios. There are certain types of joins that are introduced. So we'll go through them one by one. We'll look at some visual examples, and then what we'll do is we will take our AdventureWorks database and actually write some queries, so you can get to see in real world how does this happen. All right, so there are 3 types. Mainly there are 3 types of joins. One is an inner join, next is an outer join, and third is a cross join. Let's look at them one by one. Okay, inner join. Let's assume you have a table which is pretty simple. Okay, you have an employee ID column, the first name and the last name. Pretty simple table. But you have a second table called as, say, which just stores the salary of employees, right? So it has an employee ID and a salary. Now, what if I asked you, give me all the employees, their first name, last name, and the salary? In the previous sessions, when we had to do something like this, we would have expected that the salary column is in the same table. But here we are seeing it's in 2 different tables, right? So that means there should be some way in which we could join these 2 tables and get our results. Now, if you observe closely, you see that employee ID is common across both the tables. So I can say that employee 1, whose first name is Michael, would have a salary as 10,000 because the same employee ID is referenced in the second table. And that's where the concept of joins really becomes very interesting. Now, the speciality of this inner join, this type of join, is that you will only get the rows which are common across both the tables, right? In this case, there are 3 rows that are common across both the tables, and that's what will be returned. The thing is that there should be at least one match between both the tables, right? In this case, employee ID 1, 2, and 3 are perfect matches between both the tables, and you will get 3 rows when you inner join these 2 tables. Don't worry, we will look at an example where this will be more and more clear to you. Okay, let's look at outer joins. Okay, let's consider a table, right, which has employee ID, first name, and last name. Let's look at another table which again has an employee ID and the salary. This is pretty much the same scenario that we discussed in the previous slide, but here we are just taking a very slightly different approach. We are going to introduce a new concept called as outer joins. We introduce a third table which stores employee ID and phone number. Now, what is interesting in these 3 tables? In a previous slide, we saw that table 1 and 2 had the exact number of rows, right? You had employee ID 1, 2, 3, employee ID 1, 2, 3 in both the tables. Here we are introducing a third table called as phone number, right? But you see that employee ID 3 is missing here, right? Employee ID 3 doesn't have a phone number, and hence they haven't even entered in the table. Now, what if I told you, give me all the employees and their phone number if they have them, right? So one of your answers would be, okay, let's join table number 1 and table number 3. But in inner join, as I mentioned before, only the common rows will be accounted for. Meaning if you inner join table 1 and table 3, you will get employee ID 1 and 2, but not 3, because there is no entry for employee ID 3 in table 3. I hope you're getting the difference. Here we are not talking about common rows, right? And that's where the concept of outer join comes into play. So let's introduce the concept of left outer joins, right? Okay, let's take a table which is very simple: employee ID, first name and last name. Let's take another table, employee ID and phone number. Pretty much the same thing that we just discussed in our previous slide. Now, what happens when I left join table 1 with table 2? Left join basically says that give me all the rows of table 1. Okay, give me all the rows of table 1 and also give me all the common rows of table 2, right? But if you don't find a common row, if you don't find a join, just replace by null. Might be confusing. Let's look at the results. So you see employee ID 1 and 2 are common across both the tables. So it perfectly joined. You would have got 2 rows if you had just inner joined both these tables. But a left outer join basically says take everything from the left side table, whatever is your left side table. In this case, it is table 1. Take everything, right? Take whatever you can join from table 2, that is the right side table, and whatever you cannot join, put a null over there. So in this case, if you see employee ID 3 is not present in table 2, so it cannot join, so it simply put a null in the phone number column. If we have to imagine this a little bit visually, you say take everything from table 1 and all things that are common, right? And then whatever didn't match, replace it with a null. All rows from left table included, non-matched entries from right table will have null. Okay, so this is the main difference. Let's just take a step back. What is inner join? Inner join, just look for common rows. What is an outer join? Especially a left outer join. Take everything from the left hand side table, take everything which matches with the right hand side table, and the ones that does not match, just replace it with a null. Okay, let's look at something different. Right outer join, it's exactly the opposite. So let's take another example. Table 1, 2 rows, 2 columns, employee ID and parking spots, right? Then you have table 2, which stores employee ID and employee names. Now, how would you join these 2 tables? Employee ID is the common column which will help us join these 2 tables. But if you look at the right hand side table, it has 2 extra rows for employee ID 3 and employee ID 4, right? Now, if I right outer join, what will happen? Table 1, right join table 2, meaning take everything from table 2. And whatever matches with table 1, substitute the values. Whatever does not match, put a null, right? So that's the basic difference. When you have a left outer join, that means take everything from the left table. When you have a right outer join, take everything from the right table. So that's the major difference. So all rows from right table included, non-matched entries from left table will have null. Now, if we look at this visually, you see that everything from table 2 is included plus the common rows, and whatever is left out is substituted as null. So 3 concepts: inner join. Inner join is nothing but just look at the common rows. Left outer join, nothing but take everything from the left hand table, whatever matches, get the values. Whatever does not match with the right table, substitute a null. Exactly opposite is the right outer join. Take everything from the right hand side table, whatever matches, join it. Whatever does not match with the left table, just substitute a null. Again, we will look at more and more examples, so don't worry. Okay, we looked at left outer join, we looked at right outer join. Now let's introduce another concept called as a full outer join. Now, full outer join is actually pretty simple. It's basically a combination of what we studied before for left outer join and right outer join, right? So we take everything from left hand side table, whatever matches, take it from right hand side, substitute by null, and do the same thing for the right hand side table. Let us look at an example. So table 1, just 2 columns. Column 1, customer ID and customer name. Table 2, 4 columns over here. I'm sorry, 3 columns but 4 rows over here. You have an order number, order name and customer ID. So which is the common column across both the tables? It is customer ID, right? So now just imagine what will you do if table 1 left joined with table 2, meaning you'll have everything from here 1 and 3. So, and whatever does not match, it will be substituted as null, right? Now let's look at how things change when we do a full outer join. We take, first of all, we take all common rows, right? So when table 1 is full outer joined with table 2, the customer ID 1 is common. So you take the common set of information. Okay. Now customer ID 3 is not there in table 2, so you substitute by null. Okay. Now do the same thing from table 2. Let's look at customer ID 2. The information is not present in table 1, so we substitute a null. Similarly, we follow for all the rows. So basically it's a combination of your left outer join and right outer join. So you will have all rows from your left hand side table and all rows from your right hand side table. Whatever matches, you will find a complete row set. Whatever does not match will simply have nulls. Okay, so all rows from your left and right table are included. Non-matched entries from left and right table will have null. So if we were to look at this a little bit visually, this is how it will look like. You'll have everything from table 1 plus common rows plus everything from table 2. Again, we will look at some examples which will make it more and more clear. But the bottom line is it's just a combination of left outer join and right outer join. And in the end, let us introduce one more called as a cross join. Take an example. Table 1, 2 columns. Table 2, 2 columns, right? Department ID is basically the common column here. So cross join is nothing but this row, the first row will be joined with row 1 and 2 with the second table. Similarly, second row would be joined with 1 and 2. So each row from table 1 will be joined with every row from table 2. So your end result will look something like this. So you have 1A joined with sales and marketing, right? And then 2A2 joined with sales and marketing. So every row, if you see, every row from table 1 is joined with every row with table 2. Includes rows from both the tables. So this is a very high level overview of inner joins, where we just take common rows, outer joins, which basically has multiple things. One is left outer join, where we say take everything from left hand side table and whatever does not match with the right hand side, put nulls. Similarly, right hand side, right outer join is the exact opposite. Then we looked at full outer joins, and then we looked at cross joins. So don't worry, let's look at a few examples now.